now. So today we'll continue learn chapter 10, section 3, factoring quadratics 2. You know, in the previous 2 sections, what we learned, that's quadratics with quadratic coefficients, that's 1. Okay, now start from this section, we try to learn the quadratics with their quadratic term. The coefficients is not 1. Now let's see this example, 10.11. See, this problem, let A, B, C be numbers such that 3x minus 2 parentheses times x plus 7 equals ax squared plus bx plus c for all values of x. Then A, ask you find A, B, C. Okay, anybody, can you try this problem? And if you have answers, send me your answer in private chat. Everybody try this in your scratch paper. How to do this? Okay, so to solve this problem, definitely you need to expand this, the product of these two binomials, right? So we can do 3x times x, get us 3x squared. Then say minus 2x plus 21x, so then this one plus 19x, then minus 14. Okay, if we expanded the product of these two binomial, we can get this. So then you compare this equation left side with right side, because this equation says satisfy for all value of x. So that means A has to equal to 3. B has to equal to 19. And C has to equal to negative 14. Right? So now let's see how how is A related to the constants and the coefficients of x in 3x minus 2 and x plus 7. So then they ask you how this A related to the constants and the coefficients of x in this one and this. Say A definitely equals this 3 times this 1. So equals the coefficients of x and time together. You got this one equals 3 times 1, right? So this one gives you 3. Then now let's see C. How is C related to the constant and coefficients of x in 3x minus 2 and x plus 7? So C that's equals negative 2 times 7. So C equals negative 2 times 7. Give you this one equals negative 14, right? Now let's see D. How is B related to the constants and the coefficients of x in 3x minus 2 and x plus 7? So B, that's equals 3 times 7, 3 times 7, then minus 2 times 1, then you got this one equals 21 minus 2, this one equals 19, right? So then let's see E. Find all solutions to the equation this. Everybody try this. Send me your answer. Now, this one is very easy now. You should get this answer very easy because they already show you the factor, already give you the factoring of this quadratic. Okay, the answer Andy give us, that's 2/3 and -7. That's correct. Okay, because you already know 3x squared plus 19 minus 14 can write as 3x minus 2 times x plus 7. This one equals 0. So to make these two binomial equal 0, x has to equal 2/3 or -7. So these two numbers are the solutions for this equation. So say by this example, they show you how you can find the coefficients of these two binomials. This is very important. If you can find the coefficient of these two binomials, that means you can factor in this quadratics. If you cannot find that coefficient of the binomials, that means you cannot factor this quadratic. That means you cannot solve this quadratic by this way, right? So then the key to find this quadratic, the coefficient of these two binomials, the way you can just set their coefficients and unknowns. Then you expanded your products of two binomials, then compare with original quadratic equation. Then try to find this coefficients. So now let's see the second example. This is a 10.12. See, this example, suppose A, B, C, and D are numbers such that this satisfy for all value of y. Then they ask you find A times C and B times D. So definitely the way to calculate this, you need to expand it. This one, this left side of the equation, you can do A times C times y squared. Then plus B times C plus A times D, parentheses, then times y. Then plus B times D. This one equals 2y squared minus 3y minus 35. See, this equation, they tell you satisfy all value of y. So that means AC has to equals 2. Compare this one with this. Then BD has to equals -35. See, this BD, -35. Now they ask you to find AD plus BC. See, this one is AD plus BC. This one equals -3, right? Then say use your answers to the first two parts and some trial and error to find A, B, C, D. Okay, see, we already know A times C should give us 2. And B times D give us -35. And AD plus BC equals -3. Then they ask you try to find out what is A, what is B, what is C, what is D. So my suggestion is you always do like this way. Say A times C equals 2. You only have one way to factor this, 1 and 2, right? You can write 2 to the top, 1 on the top, 1 on the bottom. You also can switch this. This does not matter. Now, this is A, this one suppose C. Now, B times D equals negative 35. So then think, you can just try. Suppose you put 5 is here, 7 is here, then see where you need to put negative. Make the sum of these two products cross multiplication equals negative 3. So that means you need to put negative here, right? So then you do cross multiplication. You got this one's negative 10 plus 7. You got this one equals negative 3. Okay, say this one equals this, so that means this factoring is correct. So that means we can write this one as a product of y minus 5 parentheses times 2y plus 7. This one equals 0. Then by this way, we can solve y equals 5 and negative 7 over 2, right? So here, this is the difficult part. You need to try. So if you're lucky, you're not lucky, if you, because this one, that's no other alternative choice, because 1 and 2, you only can write that's 1 and 2. But 3 and 5, 35, maybe you write like this way. But then whatever you try, put a negative, any, say, you put here, you do this multiplication, you got a 14 minus 5, then you got the plus positive 9. This one does not work, right? If you do 1, 2, then negative 7 and 5, then you got a negative 14 plus 5, you got a negative 9, also does not work. After you try this, then that means you need to switch because 35, this is the one way you can write 35. Maybe you can try 1 to 35 and 1. You can try this one, also does not work. You try this one, it also does not work. Maybe because you don't have any experience, you need to try a lot of times. But when you have more experience, then you can do this quicker and quicker. But don't be frustrated when you try a lot of times, you still cannot get your correct answer. That's everybody pass this stage. You need to just keep trying, then finally definitely you can get the correct answer. Okay, now let's go to next example. This one, 10.13. See, this problem said the Cal is trying to factor the quadratic 2x squared plus x minus 45 into the product of two binomials. He first tried x minus 15 parentheses times 2x plus 3. But that does not work. Then he starts to try negative x plus 15 parentheses times negative 2x minus 3. Mary looks over his shoulder and confidently says that one won't work because the first one does not work. How did Mary know that? this one, negative x plus 15, parentheses times negative 2x minus 3, won't work just because x minus 15, parentheses times 2x plus 3, parentheses does not work. Okay, so see this problem, Kyle first try this.
One way is to expand it, and I think there's a short way too.
Okay, what's your shorter way? Say,
Like the factor and like.
yeah, let's say here. Kyle first try this, right? So then you say you get a negative 30 plus 3. You got a negative 27, right? Then later he tried this, negative 1, 15, and negative 2, negative 3. So then you can check this one, that's positive 30 plus 3. Then here should be, say, 3, negative 30. Then here, negative 1, 15, negative 2, negative 3. So that's negative 30. Yeah. So
they're the same thing. If you, either you expand it or the, factor.
yeah, say this one, that's negative 30 plus 3, that's equals negative 27. So then say, first let me explain. If this one, he found definitely, you can see this. This one equals negative 27, but then what we need is a positive 1, right? Definitely this one's not work. If this one's not work, definitely this one also will not work. Because actually this one is same with this. If you times negative 1 to this, you got this one will be 1, negative 15. Times negative 1 here, you got a 2, 3. So then say this one exact same with this, right? So if this one's not work, so here this example tell you don't try this either, because this one definitely will not work at all. You need to try the other combinations. This combination definitely will not work. So that means first, say when you write the 2 equals 1 times 2, you write this 2 as 1 times 2. Just keep here. Don't try to change this one to negative 1, negative 2. That will not work at all. Okay? Only try this one's 1, this one's 2. Because this negative, that's just exact same with this. Okay? Then you try how you can factor in this negative 45, make their cross multiplication, sum of multiplication give you positive 1. So then first you can think this one's 5, 9. So that means 5, 9. Then make this one's negative. Then you got a 2 times 5, that's 10, minus 9. You got a positive 1. So that means this one works, right? Okay, so then you got this one is x plus 5 parentheses times 2x minus 9 equals 0. So that means x equals negative 5 and 9 over 2. This one's 2 solutions for this equation. So by this example, you need to learn some trick. Here, this is a trick. Always keep the coefficients of quadratic term, this one, the coefficients as positive. Say this 2, right? If this is negative 2, both sides times negative 1, make this one is positive. Then always write this one is positive times positive. Say 2. You only need to write 2 as positive 1 times positive 2. Don't try write this one as negative 1 times negative 2. You don't need to try that. Okay? then you only need to try, say for the C, this one, negative 45. Try this one, right, like 5, negative 9, or maybe negative 5, 9, okay? But then when you say this, it works, then you just stop. If it not work, just switch the 5 and the 9 and change the signs, maybe side to here. After that one not work, then you just change this one 45 times 1. But say, because this number is very small, it's 1, right? That means you need to factor in the 45, make the two numbers are close to each other. Otherwise, how you gonna, that sum equals 1, right? If this one is a really big number, like 43 or 44 something, definitely you need to factor in this 45 as 45 times 1, right? Or at least like 15 times 3. Then make this one times 2 times that 15, okay? So then say this is an experience. I acquire this experience because I already did a lot of practice. For you, it's new to you. Don't just be frustrated. Just keep trying more, do more practice. Okay, so then we finish this problem. Now let's go to 10.15. See this one, suppose A, B, C, D are numbers such that this one satisfies. Then they ask you find AC, BD, and AD plus BC. So this one same as before, just expanded left side, then compare this both side, see what you can get. So then we can write this one's A times C, then times Z squared, right? Then plus B times C plus A times D, then parentheses times Z, then plus B times D. This one equals 12 Z squared minus 8Z minus 15, right? So then this one satisfies for all the unknown Z, right? So then we can get the AC equals 12. You compare this one with this. Then BD equals negative 15. Then AD plus BC equals negative 8, right? So then B, use some trial and error with your answers to the first part and find A, B, C, D. Now they ask you trial and error, use trial and error. Now that means, say, this one equals A times C equals 12. We can try 12 equals like, you can try, see, this one is a little bit harder, right? Because this has a lot of combinations. So first, let's try 2 and 6, right? 2 times 6 give us 12. Then B times D equals negative 15. So then now let's say we can try this one's 5, this one's 3, right? Then this one's negative, so we can try this one's negative 3, this one's positive 5. So then get a negative 18 plus 10, so this one gives us negative 8. So that's equal to this. So we are very lucky. That means this factoring is correct. So then we got 2Z minus 3 times 6Z plus 5. This one equals 0. So then that means Z equals 3 over 2, then negative 5 over 6. Okay, so this one's solutions for this equation, right? See, because I already did a lot of time. When I see this, I already have kind of tuition in. I feel maybe try this way. Definitely, I'm not sure. I feel try this way, probably can get a correct answer. But then you also need to do a lot of practice. So then we already found this the answer for this problem, right? Now let's go to next one. This one is 10.15. See, they ask you expanded 3x minus 1 parentheses times x minus 11 and 3x minus 11 parentheses times x minus 1. Everybody, can you set your answer for this one in private chat? What is your answer if you expanded 3x minus 1 parentheses times x minus 11? Everybody do this. So this one now expanded is very easy. 3 times x give you 3x squared, right? Then the middle term is a little bit hard, but then you need to do this in your mind. Say negative 1 times x, that's negative x. 3x times 11, that's negative 33. 33 minus x, so you got the 34x. Then negative 1 times negative 11, that's plus 11. Okay, Jasmine, you got it correct. Very good. Lily, you missed the middle term. And also the negative 1 should times negative 11. Okay, this one's the correct answer. Now let's expand the second one. Second one, then you got that's 3x squared. Say negative 11 times x.
But I say my answer because I don't want to type it.
Oh, you have to type. You need to give other person the opportunity. If you just see that everybody know that everybody don't want to do it. Okay. So then say 3x times negative 1, that's negative 3x, minus 11x, so minus 14x, then plus 11, right? See, compare this one with this. See, they want to teach you, if you want to make the middle number, absolute value of middle number bigger, you need to try this. Say 1, 3, then this one should be 11. This one should be 1, right? You need to try like this way. Make this number times this larger number times this larger number. Then you can make the middle number bigger, right? If you try to make the middle number smaller, you need to just do like this way. You like the smaller number times the larger number, right? By do this way, you get the middle number will smaller, right? If you try to make the middle number larger, you need to try use a larger number times larger number. Now let's try to B. B say, now let's see, May got it correct. Now let's see, now let me check Andy's result. Yeah, Andy, your answer also correct. Jessamy, you missed the X. Probably that's a typo. Okay, very good. Looks everybody know how to do this. Say this one that's equals 8x squared plus 39x, then minus 5. Now let's everybody do this. What's expansion of this? This one you got the 8x squared plus 3x minus 5, right? Yes, Lucy, you got it correct. Very good. So now let's see. Ashok is trying to factor quadratic this one. Why do the first two parts suggest he should try this? Say 5, you can just write 1 times 5, right? Say why he need to try this? 7, 1. Because this middle number is absolute value of middle number is large. We need to use a large number times large number, right? By this way, the negative 35 minus 1 got a negative 36. You need to try this. Or you need to try, say, instead of this. Definitely don't need to try this. If you try this, then you make the middle number will be smaller. See, this negative 5 minus 7, you got negative 12. But then you try to get a large absolute value, that's negative 36. So you need to try this. Make the large number times large number. Now let's go to 10.16. See, this problem asks you consider products of 2x plus 3 and 2x minus 5, then 2x minus 15, 2x plus 1, and 4x minus 3 and times x plus 5. For each product, state whether or not the coefficients of linear term in the resulting expression will be even without performing the expansion. Okay, so then they ask you consider these 3 products, but don't expand it, okay? Then they ask you state whether or not the coefficient of the linear term, so that's the middle one, okay, in the resulting expression will be even. Okay, how you can find that will be even, if it will be even. So you can just like this, say 3, this is a R number. This R number definitely we need to time this even number. That give you an even number. Then another term that, you know, for the linear term, you have 2 terms will merge together. This is 1. 3 times 2 gives you a coefficient that's an even number, 6. Another is 2 times negative 5. That also gives you an even number. So then the sum of these 2 terms will give you the linear term. That definitely, this one will be even, right? This one will be even. I use E to represent, that will be even. So second one, 15 times 2, 30, right? Because this is negative, this is an even number. Then 2 times this 1 also will be an even number. So even number add or minus with an even number, this one also will be an even number. Then for this one, negative 3 times 1, this is R number. Then 4 times 5, that will be an even number. So even number plus or minus R number, this one will be an R, right? So say you don't need the really performance expansion, but just by check the numbers to combine together to get the linear term coefficients. If they are even number, what is their product? Then you can decide the linear term coefficient is even or odd. Now, they ask you expand the products in part A and confirm that your answer is correct. Okay, this is very easy. Let's do it. The first one will be 4x squared. Then the middle term will be, say, 6x. This is minus 10x, so minus 4x minus 15. So this one's an even number, right? So second one, you got this one, 4x squared. This one minus 30x, then plus 2, so minus 28x, then minus 15. So this one, say, even number. Now this one, 4x squared minus 3x plus 20, so plus 17x minus 15. Say this one's odd, right? Okay, B, we already finished that. Then C, RB is trying to factor the quadratics, this one. Explain why RB knows not to bother check the factorization of this. Okay? Now let's say the middle term, this coefficient is odd. Now you check this. 3, 2 times 2, this one will be an even, right? 4 times 5 will be an even. So the sum of two even numbers also will give you an even number. So that means definitely this one should not give you the middle term equals 23. So that means you don't need to bother try this. So by this way, a lot of tricks then help you to reduce your number of trials. Then they can speed up your trial, right? So then we finish this one. Now let's go to 10.17. So this problem, we try to find all x such that 4x equals this. See how to do this problem. A, factorizations. Say, yuck, how can we get rid of fractions? How can we organize the equation so that it looks like the previous examples? So say this equation is not a standard form. First, when you try to solve a quadratic equation, you need to write this quadratic equation at a standard form. I mean, the standard form is like this: ax squared plus bx plus c is bx plus c equals 0. You need to first write like this form. So a and b and c are all integers, and also a is positive. So to convert to this kind of form, you need times 3, both sides. So you get a 12 x squared equals 5 minus 28x. Then both sides plus 28x. Get this one plus 28x. Then both sides minus 5. This one equals 0. So now see, this one compared with this, they have the same form. This one called standard form. Now, after you have the standard form, then you can consider factoring, okay? Before you get this one, don't consider factoring. That's harder. You need to first convert your non-standard quadratic equation to the standard quadratic equation first. Then you consider factoring. Now let's see. For this one, 12. 12, but this one's a big even number, right? So then now let's try this one. Still try to 6. Then 5. Then 1, right? say this one is a positive 28, so that means we need to make this one negative. Now 30 minus 2 equals 28. So that means this one's correct. So then we can get the product of these two binomial is 2x plus 5 parentheses times 6x minus 1. This one equals 0. Then get x equals negative 5 over 2, then 1 over 6. This is the solutions for this quadratic equation, right? See. Okay, now let's go to a harder problem, okay? 10.18. Say, find all solutions to the equation 3r minus 2, parentheses times 2r minus 5, then plus r minus 7, parentheses times 3r minus 2. So this one, say, they have the common factor this. Okay, then we can take this common factor out. We can get this one have 2r minus 5.
The solution to you.
Yeah, I got your solution. Yeah, I need to check that. Okay, give me a second. Then plus r minus 7, this one equals 0. Okay, so then we got this one, 3r minus 2, then times 3r minus 12. This one equals 0. So to make this product or binomial equal 0, r should equals 2 over 3 and 4.
I thought it was 3 over 2.
Yeah, I also got 3 over 2.
You got a 3 over 2? How you got a 3 over 2? See, this one's a common factor, right? Did you do the same way as what I did? Say this is a 3r minus 2. Take this common factor out. Then you have this one left, 2r minus 5. Now this one you have r minus 7 left. So then merge these terms together, you get a 3r minus 12. Then make this one equals 0. Then from here we got a r equals 2 over 3. Right? Then r equals 4. Now let's check. You know, first r equals 2 over 3. So 3 times 2 over 3 minus 2. This one will equal 0. So 0 times, we don't need to care about this. Then 0 times this. Definitely that's equal 0. So that means r equals 2 over 3 is a solution. Then another one, we all got the same. 4 definitely is another solution. So 3 over 2, that's wrong. 2 over 3, that's right. Okay, so now let's do the last problem in this section. For 10.19, for what value of k can 2x squared plus kx plus 5 be factored as the product of two linear factors with integer coefficients? Okay, say this problem, they ask you, what is this k? Make you can factor this one as a product of two binomials. So 2, definitely you can factor that 1 times 2. 5, you can factor this one as 1, 5. This is one way, right? Another way you can do 1, 2, 5, 1, right? Another one you can do 1, 2, negative 1, negative 5. You can also do 1, 2, 5, 1, then this one's -1, -5. So that's all way we can try. So from this, you can get 2 plus 5. This give you k should equal 7. From this one, you got this k should equals 10 plus 1 should be 11. This one, you got the -2 minus 5, you got a -7. This one, you got the -10 minus 1, you got a -11. So that means we can get k will equal these four numbers: -7, +7, -11, and +11. This one, the answers for k, right? So when you say 2, you can only write 2 equals 1 times 2. 5, that's 1 times 5. Then you can start from here. See, what is the other alternative you can get? See, we can switch the order of 1, 2 as 5, 1. 1, 5, and 5, 1. Then we also change the sign of 1 as -1, 5 as -5. Then by combining all these possibilities together, we have 4 possibilities. Then we can get 4 different k values. That's what we get, right? So we finished this section. Now let's, your homework, that will be the exercise problem at the end of this section. Now let's go to next section. This section, we try to find the sums or products of the roots of a quadratic. Roots, that means solutions, okay? See, this one is very important. Start from here, we'll find a very important formula. This formula will help you a lot to solve the problems. Even you don't need to solve the quadratic equations. Now let's see this example, 10.20. So consider equation x squared minus 8 plus 12 equals 0. Find all solution of this equation. Everybody try this. To solve this one, say this one is very easy, right? 1, you can only write 1 times 1. Then 12, that's 2 times 6. Then this one's -8. So that means we need to make this one -2, -6. So then you got a -2 minus 6, got a -8, right? So that means we can write this one as product of these two binomials equals 0. So that means x equals 2 and 6. Then B, find the sum of the solutions and product of solutions. See, we got these two solutions, right? Sum of solutions, that's 2 plus 6, you got 8. The product of solutions, that's equals 12. Now let's see how are your answers to part B related to the coefficients of the quadratic of this equation. Say this 8, the sum of these two solutions equals negative of these coefficients, right? The product of the solutions just equals these coefficients, right? So that means if we have these two solutions, one is x1, another is x2. x1 plus x2 equals negative b, okay? Suppose this one, we can write this one as ax squared plus bx plus c equals 0. So then here, it looks like you can get a sum of this solution equals negative b, right? then x1 times x2 equals c, right? For this case, right? Definitely here, a equals 1, okay? So then you can consider like this, you got this one. That's definitely correct. Now, let's go to next one, 10.21. Say, they give you the two, this time they give you the two solutions. X equals -3 and 7 satisfy this equation. Now they ask you where is A and B are constants. What are A and B? Say if you already know the solution of this quadratic equation, because we already found from the previous example, this one will equals negative of the sum of these two solutions. So sum of these two solutions give you that's 4, right? So that means A equals
-4 and -21.
Yes, that's correct. B equals multiplication of these two numbers. B equals -21. Yes. Now let's go to next one. This time, this one's a little bit harder because this coefficients, quadratic term coefficients is not 1. It's 1. If it's 1, it's easy. If it's not 1, like this, it's a little bit harder. So then first, they ask you to find all the solution to this equation. To do that, we need a factory, right? 5, we write the 1 times 5. Then 12. 12, say, because this one is a really big number, so we can try use large number times large number. Then this one's positive, but this one's negative. So then we need to move this negative here. So then we do this cross multiplication, this 60 minus 1 give us 59. So that means our factorization is correct. So then we got a product of these two binomial, that's x plus 12 parentheses times 5x minus 1. This one equals 0. So that means solution of this two equation, this equation equals -12 and 1/5. So then we got these two solutions, right? So that means we finished A. Now B, find the sum of the solutions and product of solutions. So sum of these two solutions, that's -12 plus 1/5, right as an improper fraction. So this one gives us -59/5, right? -60/5, then plus 1/5, -59/5. Then -12 times 1/5, then got the -12/5. See, this one is a sum of the two solutions. This one is a product of two solutions. Then they ask you how these two results related to the coefficients of this equation. See, then if we consider this quadratic equation as a general form, ax squared plus bx plus c equals 0. See, you can say this one -59/5 actually equals -b/a, right? -b/a. This one equals c/a. So that means if you have two solutions, x1 plus x2, this one should equals -b/a. The product of these two solutions should equals c/a. This one is exactly the formula we are looking for. Okay, so now let's go to this example. Say here, they give you for general quadratic equation, ax squared plus bx plus c equals 0. Then expanded product x minus r, parentheses times x minus s. This one you can get x squared minus r plus s, parentheses, then times x, then plus r times s, right? If we expand it, we get this. Then that's you prove the sum of the solution equals this. The products of solution equal this. That's exactly what we get, right? So then compare this one with this. You can get r plus s equals, see, compare with this, both sides need to divide by a. You can write this one's x squared plus b over a x, then plus c over a, then equals 0. Before you do this, you cannot compare. How you compare? There's a coefficients for the quadratic term is not same. You cannot compare. So first, you need both sides divided by a. Then you can get r plus s equals negative b over a, and r times s equals c over a, right? So then we prove this. This is exactly what we are looking for, okay? Now let's see the next problem. 10.24. Say here they give you the a and b denotes the solution of this quadratic equation. Ask you to find this one. So to find this one, you just expanded this one. You got a times b, then minus a plus b, then plus 1. Say here, we don't need to solve this equation. From this quadratic equation, we got the solution of sum of solution of this equation equals negative 3 over 18. This equals negative 1 over 6, right? The product of solution of this one equals negative 28 over 18. So this one gives us negative 14 over 9, right? So then we plug here, got this one equals negative 1 over 6, then minus, now change to plus 14 over 9, then plus 1. So then the common denominator, that will be 18. So this one negative 3 plus 28 plus 18. So then we can get this one equals, let's see, this one's negative 1. Okay, this one's this. A times B minus, okay. So this one's plus, this one also plus, yes. So that means this one's 15, that's 43 over 18. Did I do something wrong? So 18, this one's the oh, yes, this one's correct. Negative 1 over 6. This one is plus 14 over 9. And this one plus 1. Yeah, so then we got that this one equals 15 plus 28. Yes, 43 over 18. Now let's see 10.25. Let this one, AB is the solution of this equation. Suppose this one, this are the roots of this equation. Then they ask you what is Q. Okay, so to find Q, then say Q it's
I sent you my answer.
okay. Oh, you're so quick. I don't remember the answer yet. So product of these two solutions will give you the Q, right? So Q actually equals A plus 1 over B, then times B plus 1 over A. So then you expand this one equals A times B, then plus 1 over A times B, then plus 2. If you expand this one, you got this. Now A times B, you can get A times B from this equation that's equals 2, right? So then you got this one equal 2 plus 1 over 2 plus 2. Yeah, Andy, your answer is correct, 9 over 2, right? So this one's answer. So we already finished this section. Your homework. Finish the problems at the end of this section 2. So then we can stop here. Everybody, bye.
Like the exercises?
Thank you.
Yeah, I have all the access problems behind
Okay,
the
bye.
sections. Okay,
Bye. Have a good day.
Bye.
Thank
Bye.
you.
Bye.